Hello, Algebra 1 students, and congratulations on surviving Topic 1. Now, you may and hopefully do remember that Topic 1 was about solving linear equations and inequalities. Now, I threw that word in there because you'll see it in Topic 2, linear equations. So, one of the big questions we're going to have to answer today is, what is a linear equation? But before we can answer that, we need to look at what our new lesson is for today, and then we'll try to answer linear equations as we go through. So we should always read our lesson title, and it says we are exploring slope. Now, slope is a concept from middle school that you should be pretty comfortable with. You start talking about it in 6th grade, then do more in 7th and 8th grade. So today is all about slope, and that's why our 4th goal for the semester is essential. It's I can calculate the slope of a linear, there's that word again, function from a graph, or from a set of points. So let's start with the opener, and it's a pretty quick one, I think. The opener says, explain which line is steeper and how much steeper each line is than the others. So we, of course, have 3 lines here, line 1, line 2, line 3, and we're trying to say which one's steeper. And I bet pretty instinctively people will say line 2. And you'd be right. So as we look at those 3, we can pretty clearly see that line 2 goes up a little bit faster than line 1. Now, line 3 is an interesting little question because we're like, well, wait, if we look at line 3 going backwards and line 2 going forwards, could we compare their steepnesses that way? Now, I bet you'd still be convinced that line 2 is a little steeper than line 3, but there's 2 kind of overarching questions here that we're going to have to answer. We know that line 2 is the steepest, but the first question is, how much steeper is line 2 than line 1? And then the second question is, how do we compare lines that go in different directions if we want to talk about their steepnesses? So let's set the stage. This semester, we work with linear equations, and that's a cursive L. It's pretty common in math, so we don't think it's a 1. Well, the first thing in linear is we need to find the hidden word. And no, it's not ear. The hidden word in linear is, of course, line. This semester, we're going to be studying graphs that make lines. Many of them are going to be diagonal, some will be vertical, and some will be horizontal. Now, every line has a specific steepness, and we're going to go ahead and give that steepness a specific number. And of course, we're going to call this number the slope. The bigger the number, the steeper the line. So maybe this line has a slope of like 10, and this line only has a slope of 8. And that would let us, if we gave it a number, compare the numbers and say, oh, the actual number for the slope of line 2 is bigger than the number of line 1. Now, that also doesn't quite answer how we compare lines 1 and 2 to line 3. So we're going to go a little bit further. We say that lines 1 and 2 have what's called a positive slope, while line 3 has a negative slope. Right? And that can be a little tricky to remember. So what I like to think of is in the English language, we always read from left to right. And we do that along the x-axis, right? We start at -5 here, and we move to the right. And we know it's the x-axis. There's a little x. It's our input, our independent axis there. So we're going to move from left to right. As I move from left to right, that would be like I'm starting here, here, and here, the furthest left of the graph. Lines 1 and 2, you move up the graph, which means you are moving in a positively sloped direction. But line 3, if you picture walking up versus down a hill, you're walking down a hill, you're walking in a negatively sloped direction. Okay? Now, instead of saying the slope is a specific number, we actually give a letter for slope, and the letter we use is M. I like to think of M as telling you how the line moves. It's the movement of the line. So maybe on line 2, we'd say the movement is 10. On line 1, we'd say the movement is 8. And line 3 looks pretty similar to line 1, so maybe we say the movement is -8. Now, those numbers are, first, wrong, and second, meaningless for the slope, but it gives you a good idea of what we're going to try and do. In fact, what we're really doing here with slope is we like to explain how the y values and the x values are changing. So what that means then is if I zoom in on line 2 here and I take a look at a couple points, and this is good practice for you to remember how to name points, right? Points always go x comma y. Think the alphabet. X comes before y. X-axis, y-axis. To name this point here, we have two important numbers, -2 and -3. -2 is the x, -3 is the y, right? We're there. But then let's look at one more point on here, which is this guy right here. Oh, that's not right. 1, 0 would bring us over here. This is the point 0 along the x-axis, 1 on the y-axis. And let's see how things changed from my green point to my red point. Well, on my green point, I went from -2 to 0 along the x-axis. So my x value changed by, well, how do you get from -2 to 0? Right? -2 to 0, you add 2 by adding 2. What did the y value change by? The y value changed by, well, and if we look at the y, we went from -3 to 1. We look at that along the y-axis. It's just a fancy number line. -3 to 1, 1, 2, 3, 4. It changed by adding 4. This relationship tells us that if you want to change the x values by 2, you have to change the y values by 4. And in fact, that is what a slope is going to tell us. It's going to give us a relationship between the x and the y values. And in fact, because it tells us how fast the x's and the y's are changing, x by 2, y by 4, a lot of times you'll hear the slope called the rate of change of a line. Now, instead of writing it out with two different sentences, some very clever individual thousands of years ago decided instead of writing our slope with sentences, we're going to write it as a fraction. And they decided that the fraction is always going to relate the y values on top of the x values. If you picture a graph, right, the y-axis runs up and down, and the x-axis runs side to side. And so I bet you could probably finish this phrase. The slope, we say, is the rise over the run. Very nice. And that is because the y-axis rises while the x-axis runs. You rise up and then you run over. So let's go ahead and try a sample slope down below. We have a slope of m equals 7/3. Because the 7 is in the numerator of our fraction, the 7 means we are going to rise up 7. And of course, the axis which moves in this case up is the y-axis. The 3 is in the denominator, and because it's rise over run, then the 3 means we should run right 3 on the x-axis. Now notice that this fraction 7/3 is actually a little bit nicer than a decimal, right? We could change this to a decimal, and I have a calculator here. I could do 7 divided by 3, but when I do that, I get 2.3 repeating. And so if I see that 2.3 repeating, that doesn't really tell us how the y values and x values are changing, versus the fraction says if you change the y's by 7, you have to change the x's by 3, right? Up above, if you change the x's by 2, you change the y's by 4, right? Fractions are a much nicer way to see a slope. So let's go ahead and try these 4 down below. And if you have the time, you should pause this video and try those. They're not too bad. But if you don't, you can leave this playing. So we're going to go ahead and start with our first slope on the top left, which is a slope of -4/5. The -4 is in the numerator, and so we know that's dealing with the y-axis. Now in the numerator, we can either rise up or rise down. And it's kind of weird to say rise down, but I keep with the rise over run because why not? Now, what do you guys think? Does the -4 mean we're going to go up or down? Well, because it's negative, I bet you'll say we go down, and that's true, right? The y-axis that's up here, if you move down it, you get to the negatives, and if you move up it, you get to the positives. Okay, nothing too bad. Then, of course, we look at the denominator. The 5 in the denominator means we're going to run, right? And we've got our left, right here. Because it's positive, we think about the x-axis. Which way do you run to get to the positives? The positives are on the right. So we're going to run right 5. All right, let's try another. Slope equals 1 over negative 3. Well, the run, we have our rise, and it's positive. So it means rise up 1. You can remind yourself it's the y-axis, not a bad thing. And then we've got our denominator, which means run. Wait, which way is negatives on the x-axis? Let's see, jumping back over here, x-axis, left and right. Well, I think the negatives are on the left. So if we get this one, this is going to be run left 3, and that's going to be the x-axis. Another way to interpret this is if you increase the y's by 1, you have to decrease the x's by 3. Okay, 2 more. Now we have the slope equals negative 5 over 2. Now this one is a little bit tricky because we have a few options here. We could write this as negative 5 over 2. We could write this as 5 over negative 2. Or maybe we could write this as negative 5 divided by negative 2. Right, the negative outside the fraction is a situation we would call ambiguous. We're not really sure where the negative belongs. But luckily, we have our calculator handy. And so what we're going to do is we're going to find the decimal for the original fraction first. So we're going to go through, we're going to make a fraction here. We have a fraction button, right? And actually, I should have gone left. I'm going to put my negative first, and then we're going to do 5 over 2. And hit enter. Now it just says, great, it's negative 5 over 2. We need to change that to a fraction, and we can do that with our button right above the enter here. It says it's negative 2.5. So jumping back over here, we know the right decimal is negative 2.5. So my question for you is, which of these 3 that I just circled in purple equal negative 2.5? And you can do this pretty quickly on your calculator, but you should know the answer really just by looking at the fractions. We have a negative divided by a positive, and when you have a negative divided by a positive, that always equals a negative. So this first fraction is going to match. So these two are going to match negative 2.5. The third one is a positive over a negative. That's the same thing as this. That is also going to match. But the last one, let's try it on our calculator. Negative 5 divided by negative 2. Negative 5 divided by negative 2, that's a positive 2.5, which is a different decimal than what we started with. And so this guy, because it's positive, is not right. So long story short, if you ever get a fraction with a negative out front, you can either move the negative to the numerator or the denominator, but not both. Both will not give you the right answer. So let's go ahead and just move it to the numerator. I usually move it to the numerator and keep the denominator positive. That's just personal preference. It doesn't matter. It's not more right than the second one. And let's interpret it. Because the 5 is now negative, we need to rise down 5. And the 2 along the x-axis is positive, so we need to run right 2. Easy enough. One more. This last slope that we have over here is the slope of 6, which is a little confusing because we need slope as a fraction. But I bet many of you figured out the clever little trick with this. We can write 6 as a fraction. You can write any number as a fraction just by dividing it by 1. And I was hoping my wife was in the room and she was going to be cheering out all the answers, but no. She went to go read her book somewhere else. Oh well. So the slope is 6 over 1. We know that it is the y's or the rise over the run. And so now we can interpret this, right? We are going to rise up 6, and we're going to run right 1. Or another way to interpret this is, as you raise the y's by 6, the x's raise up by 1. All right, let's go ahead and flip to our second out of the 4 pages. And now instead of just giving a random fraction to you, let's actually measure the steepness, and in this case, between 2 points. So I have 2 points on here. I have the point 1, comma 2, and as a reminder, x-axis, y-axis, so this is our point 1, comma 2. And then we have the point 4, comma 4. We're going to measure how steep it is between those 2 points. And we're going to do it by starting at the point 1, comma 2, and we're going to rise up until we are level with 4, comma 4. So I'm going to rise up. I'm not level with it yet. Right there. How far up did I rise? Well, we want to count the spaces in between. So there's 1 space, 2 space. I rose up 2. And then I want to run over 1, 2, 3, right? 3 spaces over here. 1, 2, 3. A way you can check that is you can say, okay, I rose up 2. Rise is the y-axis. Did I go from a y of 2 and raise it up by 2 to get to 4? I did. And then I ran over 3. Did I start at 1 and go by 3 to get the new x value? I did. Now, to actually write this as a slope or as a steepness, we would write this as our rise over the run. And a fraction is a great way to go, but eventually we're going to compare the steepnesses. So eventually you may want a decimal. It's a little bit nicer when you're comparing 2 different steepnesses. So take your calculator, divide 2 divided by 3. You can start with a fraction or just type out 2 divided by 3, and you'll get your 0.6 repeating. I would suggest you keep it like this. Okay? However, you can also write out 3 6s or 6 6 6 7, something like that, but 0.6 repeating is pretty accurate. Now, the second part of this is they ask us to find the slope by starting at 4, 4 and counting down to 1, comma 2. So we're going to go down this way and over this way. Now we know if we rise down, that's a negative number. It's still 2, but this has to be a negative 2. And then if I run to the left, 1, 2, 3, going left is towards the negatives, that has to be a negative 3. So I rose down 2, ran left 3. Now you could keep your fraction as negative 2 divided by negative 3, but as we saw on the previous page, 2 negatives dividing is actually the same thing as just 2 over 3. And so it's pretty common, instead of writing a fraction with 2 negatives, to just drop it and turn it into 2/3. And you'll see that that still is a steepness of 0.6 repeating. It's the same fraction as before. So what we really measured was how steep is this line connecting the 2 points. And one way we figured it out was by going up and to the right, and the other was down and to the left. And both of those mean the exact same thing. So now let's go ahead and, instead of looking at 2 points, look at a full linear equation. We know this linear equation is linear because it looks like a line. It's diagonal. So let's start at the beginning. Does this linear equation have a positive or negative rate of change? Now remember, rate of change is how fast the x's and y's are changing. It's a fancy way to say the slope. Now we should be able to identify it quickly, starting on the far left. Am I going up or down the line? Well, we're going down, so this is going to have a negative slope. The second question asks you to identify 3 nice integer points on the line. We're going to have to break that down. It says there's 3 points, so I'm writing out 3 coordinate pairs with blanks in them. When they say integer points, though, they mean that these numbers in here are no decimals. And I'll say no decimal. I'm just abbreviating decimal right there. So they're going to be nice integer numbers. Integers can be positives or negatives, no decimals, no weird fractions. So let's find some. So we might be going down here and say, ooh, there's a point on the line. And you're right, because you should remember that a line is made up of an infinite number of points. In fact, there are many, an infinite number of points on this line. But we're actually just looking for 3 nice ones. And this point isn't a nice integer point, right? Imagine you tried to find the xy coordinate, right? It looks like the x is over here. That's somewhere in between -3 and -2. And this one's in between 2 and 3. That's not nice integer values. So as we go down, what we're really looking for is we're looking for where the x and y, that we call these like grid lines, intersect with each other. So that would be a nice point. That's -3, 4, but it's not on our line. However, I do see a pretty nice point here. I'd argue that's the point -3, 3, and I'll put it over here. What's our next nice one? Oh, this one looks pretty nice down here, right? Notice that if we start at 0, 0, we did not move right or left along the x-axis, so that's an x of 0. But then our y, we went down 1, so our y is -1. We're not doing any slopes here, we're just naming points. And sometimes students get confused on points because they're like, wait, is it x, y, or y, x? Points go in alphabetical order, x, y. But slope can be tricky because slope is y over x, and so you're used to it one way and then it seems like it's backwards. So 0, -1. Let's look at the last one. What's way down in the corner there, isn't it? That looks like 3, -5. All right, we found our 3 integer points on the graph. What do they ask us to do next? Begin at the point -3, 3 and count the slope to 0, -1. Write it as a fraction and a decimal. Okay, so we're starting at -3, 3, and we always start with the rise because our slope, our m, is always the rise over the run. So I'm going to start with the rise. And I'm not going to rise up. That would take me away from the point. I've got to rise down. 1, 2, 3, 4. I went down 4, and then we're going to run over 1, 2, 3, over 3. When you type that into your calculator, I think you should get -1.3 repeating. But check me and let me know in the comments if I was wrong there. It's good that we got a negative number because this line has a negative slope. Okay, let's find another one. Our next one is starting at 3, -5 and going to 0, -1. So we rise first, 1, 2, 3, 4. I rose up 4. Now let's do the run. Left, 1, 2, 3. Because I went left, as you move left, you get to the negative x's. That's a -3. This is the same fraction as up above, the negative just in a different place, so it's got to have the same decimal equivalence. Let's look at E. E says, and I'm going to go ahead and get rid of these because things are going to get a little messy here. E says, okay, great. Now begin at the point -3, 3 and count the slope to 3, -5. Okay, rise first. 1, 2, 3, 4, 5, 6, 7, 8. So I rose down 8. It's got to be a negative because we went down. And then to the right, 1, 2, 3, 4, 5, 6. Right 6. There we go. Now, this fraction looks different than the other two. It doesn't have 4, it doesn't have 3. But if you divide this, what are you going to get? You're going to get -1.3 repeating, right? And that's pretty cool because what that tells us is it doesn't matter which 2 points we measure the slope. And that should make sense. Think about the steepness of this piece in green right here. How does that steepness compare to this steepness? Well, they're the same steepness. What about this whole steepness compared to just part of the steepness? They're still the same slope, the same steepness. So no matter which pieces of a line you calculate the slope on, they'll have the same steepness. And so the only thing that might change is your fractions might look different. But if you remember back to middle school, we could have divided by 2. And if we did that, that would give me -4/3, the same reduced fraction as before. So if you're doing your independent practice with a friend and you get one fraction, they get another, one of the easiest ways to check to see if you're both right is turn them into a decimal. If your decimals match, then you're both right. So our answer's the same. Yes, the decimals are equivalent. Equivalent. All right. So we just talked about that. We're fine there. Let's go ahead and move on to our third page. Because we always try to approach these mathematical situations from 3 different viewpoints. One viewpoint is with an equation, and we're actually not doing any equations today. The second viewpoint is, can you apply the topic with a graph? And that's what we spent the last 2 pages on. We have a graph, we can find the slope. The third, though, is if they give you individual points without a graph, and sometimes you'll see them in a table, sometimes they'll just give you 2 points, can you find the slope? Sometimes those 2 points are really, really far apart. The example we're going to look at are 2, 4, and 6, 12. That's not that bad. But if they give you those points, I don't want to make a graph that goes all the way over to 12 and then put these points up here and then count the distance in between. So there's got to be a better way. And of course, there is. There is a slope formula. And I want to give you how the slope formula works first, and then we'll actually practice applying it. So we know slope is rise over run. Now, another way to think about that, and we can really just take it back to this previous page here, we can look at the distance between the x's and the y values. So if I start along the y-axis, if I started at 3 and I drop all the way down to -1, that's a distance of 4. And if I looked at the x's and I started at an x of -3 and I wanted to get to an x of 0, well, then I would start here and I would go over here, and that's a distance of 3. Now, you know how to find distances. If I said, how far apart are 10 and 6? You'd very quickly tell me that they have a distance, or sometimes we'd say a difference, of 4. And how did you get that? Well, you'd say, oh, I just did 10 minus 6. Very cool. You subtract 2 numbers to find their distance, and we could have done the same thing here. I could have taken 3 and -1, and I could have done 3, and here's my -1 in brown, and I could have subtracted those, and 3 minus -1 is a distance of 4. Okay? So let's see how that applies. If the rise is the same thing as the distance between the y values, then we can say that that's the change in y. By the way, as a little kind of fancy side note, sometimes you'll see change in y with a triangle. That's the Greek letter delta. It means change in. It's how far apart 2 things are. And of course, the run is going to be the distance between the x values, or the change in x. Sometimes you'll see this as delta x, the Greek letter delta for change in. Now, that's great, because if we want to find the distance between 2 y values, we just take one y value, in parentheses, and we subtract the other y value. But there's a small issue, because if I just do y minus y, you'd say, well, anything minus itself? That's 0. That's super easy. Y minus y is 0. But the distance isn't always 0. These 2 y's are actually standing in for different y values. And so we have to tell the reader or the student that they are different. And the way we do that is we use little numbers called subscripts. So subscript. Okay? And what we do is we give these y's a little subscript. We say y sub 1 and y sub 2. Y with a subscript of 1, y with a subscript of 2. And so you can think of this as like a first y value and a second y value. And now they're different y values, not always 0. We'll, of course, do the same thing with the x's. To find the distance of the x values, we take the 2 x's and we subtract them. It is important to note that if you use the first y value up here, you need to use the first x value directly underneath it, and then the second x value. It's also important to note that this slope formula is usually written the other way around. It doesn't matter, you get the same answer, but traditionally we write this as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. With a reminder that these little numbers aren't any math. They're not exponents. They're not squares up here. They're just showing us that the x's are different. So let's go ahead and actually do an example with this. So given a linear graph that contains the points 2, 4, and 6, 12, we're going to calculate the slope between those 2 points. And all of this is really just going to take you through the process. When you actually practice down below, you'll do this much faster. So the first thing we need to do is label our points as x1, y1, x2, y2. And the first challenge is remembering if points are x, y or y, x. Well, we've talked a few times today that it's alphabetical order. Points go X and Y. So up above, I have my Y's and I have my X's. X, Y, X, Y. Now I need to give those numbers subscripts so we can use our formula. So here we go. That means in the point 2, 4, the 2 is an X, while the 4 is a Y. And of course, in 6, 12, the 6 is an X, while the 12 is a Y. Now, as we read from left to right up here, the very first number we get to is a 2. And because that's the first X that we reach, we're going to call 2 X sub 1. The second X that we reach on our journey from left to right is an X of 6, and so that's going to make 6 X sub 2. It's the first X we get to and the second X. Then we do the same thing with the Y's. Left to right, the first Y we reach is 4, which is Y sub 1, and the next Y we reach is 12, which is Y sub 2. So we gave 1, 2, and we gave this one a 1 and a 2. The order is important. X1, Y1 need to be together. X2, Y2 need to be together, though you could switch the order if you wanted to read it backwards. Then we're going to calculate the slope between the 2 points. Now, don't forget, when you do your slope formula, this is the most common mistake students make. The y values go on top. It's the rise, the y's, the rise over the run. And so we start substituting points in. y2 minus y1 over x2 minus x1. I am going to insist that you put the parentheses to start with, and as you get more comfortable and know when you can leave those parentheses out, great, but for now you must put them. All right, so what was our y sub 2? Oh, it looks like 12. So y sub 2, this whole thing is getting replaced with 12. There's no more sub 2, because now we've said the second y was 12. What was the first y? That looks like 4. Okay. And we can just do 12 minus 4, which is 8. And in fact, this is a good way to do it on your calculator. Do the top first and the bottom second. Then we do x sub 2, which up here, x sub 2 was 6, and x sub 1 was 2. 6 minus 2 is 4. If you type 8 over 4 into your calculator, it will tell you the overall slope is 2. And that's great for an answer. We could also write it as 2 over 1. In fact, any of these answers are great for a test. They all mean the same thing. The steepness of this line we're describing has a steepness of 2. All right. So to finish off this page, we're going to go ahead and talk about the 4 different types of slopes which can occur for linear equations. Now, I'm not even going to tell you what the description is first, or even the example. What I'm actually going to have you do first is find the slope for each of these points. Then once we've found the slope, we'll see if we can figure out what the graph would look like, and lastly, we will describe it. So, if you want some time, you can go ahead and pause me, but you're going to take these points, put them into the slope formula, find the fraction and the decimal. You're going to do it for all 4 of those. If you have time, pause me and do it. If you don't have time, then you can keep listening to me preach. All right, so here's how I do this. I label my points with x's and y's, and I'm going to stop with the fancy colors because it takes me too long. So we have x, y, x, y. Then we label from left to right what we get to first. My first x, this is my first y, second x, second y. And then we start substituting them into the right place. So if you look up above, it's the same formula every time. We start with my second y, which is 5, and my first y, which is negative 3. Second x, negative 1, first x, negative 2. Now, a lot of students get thrown off with these double negatives, right? 5 minus negative 3. We might remember from middle school 2 negatives right next to each other are a positive. That's 8. But if you're ever unsure, don't forget that on your calculator, you could type everything in, right? We have, and we'll clear this out for you, we have the fraction, and then we want to get those parentheses as well. So we've got 5 minus, and then we need to get negative 3. And it's very important on your calculator you get those separately. Same thing down below. It was negative 1, and I promptly forgot what the other one was, minus negative 2. So minus parentheses negative 2. And if you get that all set up correctly and hit enter, it'll tell you it's just 8. But your math skills should be good enough that you don't need a calculator here. -1 plus 2 is the same as 2 minus 1, which is 1. So this is 8 over 1 is a fraction, which is fine for an answer, but anything over 1 is just itself. Let's look at our next one. M equals, we're going to set up our parentheses like so, and we'll label our points. X, I thought I said red, but apparently I picked highlighter. X, Y, X, Y, X1, Y1, X2, Y2, and the more you practice, of course, the better you're going to be at this. The second Y, first Y, second X, first X. Okay. I'm going to do this without a calculator with the expectation that if you do need help that you can do this on your calculator, but 0 plus 3 is going to give us 3, and -3 minus 0, we're not changing at all, is -3. Any number divided by itself is, of course, -1. So two different answers, they mean the same thing. It's a steepness of -1. Jumping down below, same idea again. We'll go purple this time. So we have x, y, setting up our slope. Like so. And it is x1, y1, x2, y2. So y2 is 1, y1 is 1, x2 is 3, and x1 is -2. Okay. 1 minus 1, well, anything minus itself is always 0, so that isn't too bad. 3 plus 2, that gives me 5. But what about this guy, 0 divided by 5? That could be a little tricky. I bet a lot of you would guess at the right answer here. I like to think of it as if you had $0 and you split that among 5 friends. You said, hey, 5 friends, I have $0. I'm going to split that among you. How much does each person get? Each person gets $0. So 0 divided by any number will give us 0. Last but not least, we have our x, y. I said blue, but maybe not. X, y, x, y. Now I'm sure if I go back over it will be good. And we'll do our slope one last time. Okay, so we have our first x, first y, second x, second y, -3 minus 1 divided by -2, I missed the minus in there, -2. -3 minus 1 makes it one more negative, -4. -2 plus 2, or 2 minus 2, is 0. Now, I wouldn't fault you for trying to use the same logic here, but I think you'll find that this one probably isn't 0. And you can see that in two ways. The first way is if you ignore the negative, I'll put it back. If you have $4 and you go up to 0 friends and say, how much does each friend get? Well, you don't have any friends there, so it's not really a question. It's not really a sensical question. We can't split $4 among nobody in front of you. And it's not even right to say everyone gets $0 because there's nobody there to receive $0. But if you're not sure, you can always try it on your calculator, right? -4 divided by 0. And we do -4 divided by 0. And when you try that, your calculator will say, error. You cannot divide by 0. And so the most common way that we write our answer here is we write D, N, E. And of course, D, N, E stands for does not exist. We are not allowed to divide by 0. I usually joke that your calculator doesn't let you divide by 0 because if you're actually able to, the world explodes. So it's a very good safety feature of your calculator. Now let's backtrack. What are we actually trying to do here? Well, let's look at this description of the slope that we just found. A linear equation whose slope in simplest form is something will move diagonally upwards from left to right. So diagonally up from left to right, that looks like this. Oh, I bet they're talking about the sign of the slope. A linear equation whose slope is positive looks like the graph that I drew over there. Well, on the next one, I bet if the slope is negative, it will move diagonally downwards from left to right, like so. But what about these last two? 0 and does not exist are neither positive nor negative numbers. But I bet you already know what a slope of 0 is, right? If we think about slopes here, and we have kind of a small positive with a slope of 1, and then steeper with a slope of 2, and steeper with a slope of 3, if we go the other way, and I go a little bit less than 1, and maybe now I'm at like 0.5, what does the slope of 0 look like? And hopefully you're thinking, oh, a slope of 0 is horizontal, it is flat. Don't say it's straight, all these lines are straight. Yeah, it's true though that a linear equation whose slope is 0 will move horizontally from left to right. It doesn't have any steepness. However, the weirdest one is this last one. This does not exist. And so I'll even show you a slope that does not exist as we kind of go this way, right? So if we have this steep line, which is 1, and then I make it a little bit steeper, now maybe it's a slope of 2, and then I make it a slope of, let's say, 50, and then I make it a slope of, let's say, I don't know, 1,000. It's still not quite up and down. As I move closer and closer to vertical here, this number gets bigger and bigger. And so actually, sometimes you'll see a vertically sloped line said that it has an infinitely steep slope, right? I gave you that infinity sign, that sideways 8. And that's actually what this dividing by 0 is giving us. It's actually telling us it's infinity, but we go it does not exist. And so we say a slope, or an equation whose slope is dne, will always move vertically. It's an infinitely steep slope. It's really, really, really steep. So let's go ahead and finish off class today with 2 more quick concepts that I bet you probably know at least one of the words for, but maybe aren't quite sure how they fit in with lines. So the last part of today is a discussion of 2 types of lines that we're going to talk about a lot, and they have some pretty special applications in math. The first one is a little bit more straightforward. You're probably going to be asked to determine if 2 lines are parallel. Now, if I asked you to hold up your arms right now, you would show me 2 parallel lines perfectly, right? 2 parallel lines could be diagonal, they could be vertical, and the only requirement is that they don't cross each other. Now, the mathematical word for that is we say they do not intersect. That's on here. And this happens, they don't run into each other because their steepnesses are the same. They're going up at the same rate. And if they have the same steepness, that of course means they have the same slope. So if, hypothetically, I were to give you 3 different lines down below and ask you which of the lines are parallel, how would you do it? Well, hopefully by using the information up above, you'd say, oh, let's just find the slope for each of these 3 lines, 1, 2, and 3, and then just compare and see which of the lines have the same slope. If they have the same slope, they're parallel. If they don't, they're not. They would intersect. Now, I've tried to give you a variety of lines here, where our first is a graph of a line, and you can look back to page 2 on how to do that. Our second one gives you 2 points on a line, and then our third one goes all the way back to early middle school and gives you a table that if you were to graph makes a line. And your job is to find the slope for each. So if you want a good challenge, you should pause me and go for it, but if you don't have the time, you can keep on listening. So here's the graph of line 1. Now, in order to find the slope of a graph, I suggest you don't use the slope formula. Do what we did on page 2 and go back through and find your nice integer points. And there are many on this graph, right? There are at least 6 that I see here. And then to find your slope, we need to find the rise over the run. So I'm going to go ahead and pick a point, doesn't matter where, I'll pick this guy, and I'm going to see how long does it take to get from the first point to the second. And I'll do it by rising up first, that's up 1, 2, and running over 1. So up 2 over 1. And because we want to compare these, we should probably divide these out. But we don't even need to divide. Any number over 1 is just itself. So line 1 has a steepness or a slope of 2. Let's try line 2. Line 2, oh, that we just did a whole bunch of these, right? We know how to do this. X, Y, x1, y1, x2, y2, and then we say the formula. It is y2 minus y1 divided by x2 minus x1. Let's clean this up. 2 minus 0 is 2. 1 minus negative 3 really means 1 plus 3, which is 4. And although you could leave it as 2 over 4, hopefully you would know how to reduce that fraction dividing by 2's, right? Doesn't that give us the fraction 1/2? 2 parts out of 4 is the same as 1 part out of 2. And I bet you even know the decimal equivalent for 1/2, right? That's 0.5. So if we ask each other, are line 1 and line 2 parallel? Certainly not. Line 1 has a slope of 2, line 2 has a slope of 0.5, and those are not the same, not parallel. All right, must come down to line 3 then. Ooh, this one looks weird. We have this table. Now, if I wanted to graph this table, and you do a lot of this in middle school, what we would do is we would take each x and y and we say they form a relationship. And a relationship means we can graph them as a coordinate pair. So I could actually take -2 comma negative 22 comma -7 and treat that as the point -22 comma -7, and we would graph it over here, -22 comma -7. But we don't need to graph because we have a slope formula. So I'm going to quickly write these points over on the side just so I don't have to do it in the middle. So we have -22 comma -7, -16 comma 5, -8 comma 21, and -2 comma 33. We have 4 points here. And when we had 2 points on the second problem, we just used the slope formula. So how do we find the slope with 4 points? And the answer comes back to, again, what we did on page 2. Page 2, we had 3 different points on a linear equation, and we said it didn't matter which 2 points we found. These 2 had the same slope, these 2 had the same slope, and all of these together had the same slope. And so the trick for this is, when you want to find the slope and you're given many points, you just pick 2 of them, and it doesn't matter which 2, you'll get the same answer. So I think I'll just pick the red one and the brown one, the first and the last one, and let's go through and label them. Now notice we already know what the x's are, right? The x's come first, like this, and the y's are, of course, second, like so, like so. So we just go through and we label them like before. Y sub 2, x sub 2, y sub 1, x sub 1. And don't get confused about which is which. It doesn't matter. As long as your x1, y1 are together, x2, y2 are together, you'll get everything right. Slope formula. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay, let's work this out. 33 plus 7 is certainly going to give us 40. -2 plus 22, I'd prefer to think of that as positive 22 minus 2, which is 20. We can use our trick of chopping off the zeros, so we just get 4 over 2, and 4 divided by 2 is 2. All right, let's answer our question. The graphs that are parallel are, let's see, where are the slopes the same? Aha! I think line 1 and line 3 have the same slope. So it's got to be line 1 and line 3. I know this because they both have the same slope, m equals 2. That's all we need for parallel lines, same slope. All right, we're going to finish off class today with one more pretty complicated sounding word. The last type of lines you need to be familiar with are known as perpendicular lines. Now, perpendicular lines are not the opposite of parallel lines. Students will say, oh, parallel lines don't intersect, perpendicular lines do cross. And although that's true, not every set of crossing lines are perpendicular. Perpendicular lines are linear equations that intersect at exactly a right angle. Do you remember middle school? How many degrees are in a right angle? Yeah, 90 degrees. So let's go ahead and look at A. Right? A says lines 1 and 2 intersect, but they are not perpendicular. So maybe I can add some color to this. Here's line 1, right? Here is line 2. And so what they're telling us is that these intersect, but they're not perpendicular. How do we know? Okay, well, we know that, I think, and this is honestly pretty tough to tell, which is why we're doing this. I'm going to argue that this angle is not 90 degrees. And so if it's not 90 degrees, they are not perpendicular, right? This angle up here is also not 90 degrees. But the tough part is it's pretty close, right? 90 degrees we draw as a right angle like this, and it's just a little bit too far, I think. But then they go through and they tell us that lines 1 and 3 are perpendicular. And honestly, if I were looking at these, I would be pretty tempted to say those are not a right angle. But it turns out that they are. So let's go ahead and look at these slopes, since that's the point of today, of line 1 and line 3. And so I'm going to go ahead and keep line 1 highlighted in red, and I'll highlight line 3 in purple. And they asked us to find the slopes. We have graphs, so the fastest way to find the slope is just to count. So I'm going to pick my 2 integer points for the red one. Looks like we go up to over 1. So for line 1, so I'm going to say m of line 1 is going to be up to over 1. Now let's do line 3. Line 3, I'll again pick 2 integer points. And this one tells me I go down 1 to the right 2. So m of line 3 is going to be down 1 to the right 2. Do those slopes look related to each other? I would say they both have 1s and 2s, and they're pretty much the same, but the fractions are flipped over versions of each other. And of course, one's positive, one's negative. It should make sense that if 2 lines cross at 90 degrees, generally one slope will be positive, one will be negative, right? If they're both going up, they're not crossing at 90. One of them's got to go in a downward direction. Okay? So if you can't perfectly see that 2 lines intersect at exactly 90 degrees, how can you tell for sure that they're perpendicular? And the answer is look at their slopes. And in particular, there are 2 qualities of the slopes that we need to investigate. 2 lines are perpendicular when they have opposite, and opposite means change the sign of the slopes, right? This slope was positive, this slope was negative. So one slope is positive, one slope is negative. And then what do we call 2 fractions that are flipped over versions of each other? We've talked about it a couple times from our first unit. Oh, that's right. They're called reciprocals. I'm going to say reciprocal. So 2 lines are perpendicular when they have opposite reciprocal slopes. And that's actually pretty easy to find if you have a slope. So a fancy symbol for perpendicular is this upside down T. Why? Well, if you think of these as 2 different lines here, these 2 lines meet at a right angle. They're showing you that they are perpendicular. So what they're asking us to do to finish this off is I say, what slope is perpendicular to a line with a slope of 4/5? Well, it's pretty easy. We draw a fraction. We find the reciprocal of 4/5, which is 5/4. And then we make sure they have opposite signs. 4/5 is positive, so 5/4 needs to be negative. Remember, the negative can go in the middle, the top, or the denominator, but I'll just leave it in the middle. All right, let's look at our next one. Perpendicular to a slope of -1/2. Well, we find the reciprocal, 2/1. This slope is negative, so the opposite reciprocal needs to be positive, just 2/1. Or, if you wanted, that's the same as just 2. Perpendicular to a slope of 3. Well, we know that if that's a slope of 3, that's a positive. My new slope has to be negative. But how do we find the reciprocal of 3? I think it might help us to look at 3 as a fraction. 3 over 1. Very nice. So we flip it, and the reciprocal of 3 is negative 1/3. Last but not least, we need perpendicular to a slope of negative 1. So same trick as before, negative 1 over 1. We need to reciprocate the fraction or flip it over, 1 over 1. The original was negative, the new one is positive, and you could just say that's also 1. So let's conclude and talk about what we learned today. The first thing we learned is that slope just measures how steep a line is. If you're given a graph, counting the slope is almost always the fastest way to find that, and it's rise over run. However, many times you'll be given 2 points or even a set of points in a table. And if you're given those, then we usually want to use the slope formula. y2 minus y1 divided by x2 minus x1. And we will give you that on your knowledge check and your test. You don't need to memorize it. At the end of our slope questions, you're going to be asked questions about parallel and perpendicular lines. Parallel lines never intersect or cross, which means they have the same slopes. Perpendicular lines do cross, but they do more than cross. They cross at exactly a 90-degree angle. And slopes of perpendicular lines turn out to be opposite reciprocals. Flip the slope over, change the sign. So hopefully you're feeling a little bit better on reviewing these slopes that you learned in middle school, and whenever you're ready, you can go ahead and get that independent practice out of the way. The rest of this unit is going to focus more on these linear equations, how we actually create these lines, but slope is really a key component of the lines that we need to understand before we start drawing them. So thanks for tuning in, keep up the great work, and good luck in this unit.